Today, we're pulling back the curtain on a technology that's pretty much invisible, but it armors everything from jet engines to our own bodies. We're talking about a microscopic shield just atoms thick that is absolutely changing our world.
So, have you ever stopped to wonder about this? I mean, think about the insane conditions our technology has to put up with. You've got a jet turbine spinning in blistering, metal melting heat, or a solar panel that needs to soak up every last ray of sunlight. How in the world do they not just fail? Well, the secret is a microscopic shield, a super precisely engineered surface that changes everything. Yep, we're talking about advanced chromium-based coatings. They are the true unsung heroes, making our tech tougher, our energy cleaner, and as you'll see, even our bodies healthier. So here's what we're going to dive into. We'll start with how these coatings are changing the game for solar power. Then we'll look at how they protect our toughest machines, their surprising role inside the human body, and finally, what the future looks like for these incredible surfaces. All right, let's kick things off with one of our biggest challenges, renewable energy. See, to make solar power really work, you have to be crazy efficient at capturing sunlight, and that's where this special coating called black chrome steps onto the stage. You can basically think of black chrome as a supercharger for solar panels and water heaters. Its one and only job is to just greedily absorb as much solar radiation as it possibly can and turn it into pure, useful heat. This makes the whole system way more powerful and effective. The secret sauce here is a principle called low emissivity. Okay, imagine a perfect thermos, right? It keeps your coffee hot for hours because it doesn't let the heat escape. Black chrome does the exact same thing for a solar panel. It's fantastic at absorbing heat, but it is just terrible at letting it go. It holds on tight. So it's this critical two-step process that makes it all work. First, the coating's unique microstructure is basically a light trap. It maximizes absorption. Then, that low emissivity property kicks in and holds onto that energy, stopping heat loss in its tracks. It's this one-two punch that makes it so vital for renewable energy. Now, let's switch gears. We've gone from capturing energy to surviving it. In the world of extreme machines, the challenge isn't soaking up sunlight. It's withstanding just brutal conditions. We're talking about wear, corrosion, and incredibly intense heat. When you're dealing with aerospace superalloys, these are metals designed for the most mind-bending temperatures you can imagine, or heavy industrial tools, failure is simply not an option. That's why engineers turn to two powerhouse coatings, chromium nitride, or CRN, and chromium oxide, CR2O3. These are the heavy-duty armor plates of the microscopic world.
But not all armor is created equal. As you can see here, chromium nitride, CRN, gives you this fantastic balance of hardness and adhesion, how well it sticks. That makes it perfect for tools and those super alloys. Chromium oxide, on the other hand, is just exceptionally hard. It was the hardest in one study, which is ideal for parts that see a lot of wear and tear, even if it sometimes sacrifices a little bit of stickiness to get there. And this quote from the research really nails that critical engineering trade-off. It's a choice, right? Do you need the absolute hardest surface possible, even if it might be a bit more brittle, or do you need a coating that sticks like glue under extreme stress? The answer totally depends on the mission. So, how do they even make these things? Well, it's a serious feat of engineering, using high-tech processes like physical vapor deposition, or PVD. The best way to picture it is like spray painting with individual atoms, letting scientists build the coating one layer at a time. And you need that level of precision when you're applying it to advanced materials like waspalloy, a superalloy used in jet engines, or your industrial workhorse, S37 steel. Okay, from jet engines to something way more delicate and complex, the human body. It might sound a little strange, but these ultra-hard coatings play a vital, totally life-changing role in modern medicine.
And this is a huge challenge. I mean, the inside of our body is a warm, salty, and surprisingly corrosive place. So how on earth do you make sure a hip replacement or a dental implant not only survives, but functions perfectly for years, maybe even decades? And the answer, once again, is chromium oxide, When you apply it to medical-grade stainless steel, it becomes a total game changer. It creates a super slick surface to cut down on friction in joints, it resists wearing down from decades of movement, and it forms this impenetrable barrier against corrosive body fluids. But maybe most importantly, it's biocompatible, which means the body just accepts it. And here's the really cool part. The exact same properties that let an implant last a lifetime inside a person also make these coatings perfect for high-end decorative stuff. That toughness, the corrosion resistance, that beautiful shine, it's why you see them on luxury car trim and designer faucets. It's high-tech armor that also happens to be beautiful. So we've seen how incredible this technology is, but all this power comes with a pretty significant dilemma, and that brings us to the future of these chromium coatings. It's a real trade-off. On one hand, you get unmatched hardness, amazing corrosion protection, and incredible versatility. But on the other hand, some of the traditional ways of applying it can involve really toxic chemicals, like hexavalent chromium, which is the most hazardous form. And while the modern processes like PVD are cleaner, they are also expensive. And sometimes the very hardness that makes the coatings so great can also make them brittle. And that leaves us with this final, really critical question. The demand for better, stronger materials is only going to grow. So the challenge for the next generation of scientists is to keep pushing the boundaries of performance while finding sustainable ways to create these invisible shields. Can we engineer the perfect surface, one that protects our technology, our bodies, and our planet all at once? The race to build that future is happening right now.